Okay, this is the simulation of the code written in Allen Bradley. I created a add-on instruction for each conveyor. If you see over here, I have, let me see, I got a motor for each section of the conveyor. So this section is controlled by a BFD. It could be BFD or it could be hardwire. So it doesn't matter, but the AOD is able to control each sections independently. So you write only one piece of code, and then you are able to control each one of them separate. So I'm going to go ahead and run everything and start with the HMI. The HMI I have right now, it's Siemens, because I did not have factory IO, factory talk simulator HMI. So right now, if I press my start button, nothing happened because I am not in automatic mode. So I have to change this to auto in order for me to start the process. So I'm going to go ahead and click on start and see if see how it runs. Okay, I'm going to put it in pause, the simulation, to show you that each conveyor and each turntable are indeed individually. So what I'm going to go ahead and let me see if I can talk while this is it's running. Let me go ahead and start it again, and let me lower the volume maybe a little bit. So right now, what I'm going to do is inject a failure on this turntable. So the other loads coming in should continue running independently until all the stations are completely filled up. Even though this turntable, I am going to go ahead and inject a failure over here. I got my AB lifter, and I'm going to go ahead and put a failure on it right now and run it. As you can see, this one kept running. This one's keep running until the entire conveyor is filled up. And also the turntable is still running again. So what I'm gonna go ahead right now is to simulate a forklift coming in and grabbing this load off the top of the conveyor. Okay, so I'm gonna grab this box and take him out completely and see what happened. Sure, we could program some safety security, but right now the reason I did this is just to show you that each AOI add-on instructions, it's behaving as it should, controlling individually each conveyor by looking at this photo eye and saying that there's nothing there, therefore I could go ahead and fill up that position with a new pallet. So let me try this one again. Let me just get rid of this box over here and the pallet. Whoops, my bad. So let me do it again. So I'm gonna go ahead and do it in real time just to see what happened. I'm going to do it on these two conveyor, and I'm going to remove the load from this, also from the turntable. So I'm going to go ahead and undo this with the turntable and see what happened. Good, that's exactly what I wanted. So let's put everything back to run and show you the entire sequence once again. And then let me get rid of this turntable. Go ahead and get rid of this injecting failure here. Everything should run normally now. So I'm going to go ahead and get rid of this, clear everything, and see how the machine runs in auto mode and manual mode. Right now, as you know, I changed this over here from auto to manual. And manual, there's no way I can start running anything, but I am able to move independently each conveyor. If we go over here and bring the HMI, you see this pallet over here, we can move it forward or backward directly from the HMI. I can also work with the turntable and see over here the roller on the turntable, then move forward and backward. I am able also to capable of turning the turntable by clicking on this button. And also I am able to control the other turntable over here, right over here, by this one over here. This is the wrapper outfit. See? So I'm going to do it again. So what happened if this load has to be, let's take this as an example. The reason there might be a need for moving this load all the way to the end of the turntable. So both conveyor have to run sequentially or synchronously, okay? So I'm gonna go ahead and move the load manually, back and forth, with both conveyor running. So in other words, this button over here, this little one, will allow me to run this M5 conveyor and the M6 conveyor at the same time, back and forth. Or I could do it individually, like that. And this one also individually. And this conveyor would be number 7, forward, backward, reverse, and forward. So that's the whole application. And I'm going to go ahead and show you the code that I wrote on Studio 5000, okay? All right, this is the code that I wrote. This is based on my main routine, calling my subroutine conveyor over here. Okay, this is the code I wrote, which is based on my main routine calling this subroutine called conveyor. And this is where I have all my AOD. The simulation that you just saw inside Factory IO, this is a simulator program. I'm going to show you a little bit more about that program that I used. So it's just based on this AOI that I wrote. This is my AOI for the conveyor. And this is the AOI or iron instruction for my turntable. Those two iron instruction over here, this one and that one, controls the entire sequence. So everything starts by telling my system that I am ready to run. If I press the start button, Factory IO is running. Man mode is to my auto mode. Nobody has pressed my stop button, and I do not have any model fault coming from the VFD or from some disconnected switch on the conveyor. Then I am able to go ahead and boom, run everything. So this is my machine ready bit inside my AOI. This is my ready to run. So inside this add-on instructions for the conveyor, the magic happens in all these 1, 2, 3 lines of code. The reason is because I'm looking all the time. I'm looking at my photo eye on the conveyor. I'm telling the infeed and the outfeed conveyors if I am able to receive a load or to give a load. Am I ready to give or am I ready to receive a load? Okay. Over here, I go ahead and initiate my contactor, moving the conveyor forward or reverse in manual mode of down here by using this run over here, or I could do it in auto mode by looking at my photo eye or waiting for the outfeed conveyor to tell me that it is ready to receive, ready to give, right? This is all the instruction needed inside this AOI. I only wrote it once, and every time we put a new conveyor on the line, we just go ahead and instantiate another sample, another AOI into my run my logic, and that AOI will be controlling either M5 conveyor, M6 conveyor, M7 conveyor, M8, and M9. All 9 conveyors are being controlled by these add-on instructions. So the add-on instruction, I had to create a new one for the turntable, since the turntable has much more complication, maybe IOs, different IOs. So over here, it's I am ready to give signals to the infeed and the outfeed as to what state am I. Do I have a load, a pallet on top of the conveyor or not? And then this is the additional run that I had to write to rotate the turntable in manual and in auto mode. Over here, everything is pretty much the same as the other one. By moving the, turning on the contactors on the VFD or the hardwire contactors for moving the conveyor either forward or reverse. So that's it. That's all the logic there is to it. I did not write anything else. My IO tree is based on the simulation that I'm doing, because it is based on this Memulex that I'm using with my simulator. So I only have my IOs and the simulator configured inside my IO tree. All right, I'm gonna go ahead and pretty quickly show you Factory IO. This is the program that I use when somebody subcontract my services. I am able to at least to be able to program the entire, well, I would say like 75, between 60 to 75% of the project sitting anywhere else but on the site. Meaning that I could be on the airport and running this simulation and doing the actual programming. So I'm going to go ahead and teach you how I use that for my projects. Okay guys, this is the program that I use for simulating projects. This Factory IO is a emulation and simulation program for Allen Bradley PLC, Siemens PLC, and those PLC from other manufacturers like Omron, Mitsubishi, Automation Direct, that uses Modbus TCP for communication. So I am able to program any PLC most of the application, a big chunk of it, maybe 60% of it, sitting at my home or at Starbucks, and be able to test my code in real time using this program. I'm going to show you a little bit of what the program does and what can I do, what type of project I can accept or program or maybe simulate. This is the different scenarios that they have. So in starting, including process, like tanks, for filling tanks, conveyors, and very complicated stuff like automated warehouse. So I would be able to program these two using this either PLC, Siemens, or Allen Bradley. This is a very sophisticated program, and the good one of the features that I like the most is that I am able to use all this PLC over here. Right now I have the license for Siemens. I also could buy the license for Logix 5000, but the only problem is that the reason I do not have it is because this driver over here does require me to have an actual PLC sitting on my, with me. If I'm at the airport, I will not be able to use this one, but the reason I bought Siemens is because I could use the simulator on Siemens, and the code I could write the code inside Siemens and then export it or write it or convert it to any other PLC, as long as the ladder logic, the customer does require me to use ladder logic as opposed to structured text. If it's ladder logic simple, the standard one, I will be able to use it very quickly. So this is the program I use. I want you to know that this saves a lot of time. I don't have to be sitting in front of the customer for so long. I could spend a couple of weeks, at my home, anywhere else, programming, controlling the application, either with robotics or without it, including button, HMI, SCADA, and PLC. All right. Well, thank you very much. Appreciate it. Bye-bye.